Now we're going to look at how to find zeros if a polynomial of any degree is graphed. Well, let's start with a polynomial of degree 4. You can't see the full function here, but you should kind of know how a quartic function acts, and it kind of looks like this. It gets cut off here, but it goes down and comes back up. But really all you need to know to solve problems like this is where it crosses the x-axis. So as long as you can see the whole x-axis, or at least the part of the x-axis that matters, we know because it's a quartic it's not going to come back down on either end, that as long as you can see that part of the x-axis, you can solve this problem. Now keep in mind, just so you know, in case you haven't encountered this before, you know this doesn't come back down because n is 4. It's a degree 4, so you have 1 hump, 2 humps, 3 humps, 3 maxes and mins. If n is 5, there are 4. If n is 6, there are 5. You take n minus 1, n being the degree of the polynomial, and that's how many of these little maxes and minimums you should have, these little humps in the function. We already have 3, so we know it's not going to do it again. That's how we know it doesn't come back down. So we know we're looking at all the information that we need. We have the function crossing the x-axis at -1, the function crossing the x-axis at 1, the function crossing the x-axis at 3, and the function crossing the x-axis at 4. So our zeros are -1, 1, 3, and 4. And our p of x is the quantity x minus 4 times the quantity x minus 3 times the quantity x minus 1 times the quantity x plus 1, which when you multiply it out comes out to be x to the 4th minus 7x to the 3rd plus x to the 2nd plus 7x minus 12. Now let's get really tricky. Let's add a much higher degree. Let's go up to 9 degrees. N is 9. So now there are a whole lot of zeros we can be looking at, right? So we're going to have, let's pick something tricky here. Let's do this. So we have 9 zeros, right? So you can see it here, 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 you can see it here. One actually shows up twice, so we're not going to do that because that gets a little tricky. We're going to do this. We're going to have, there we go, that should work, right? That's 9, 1, 2, 3, 4, 5, 6, 7, 8. There's another repeat somewhere. There's 2 negative 1s. We'll make this -3. There we go. Now we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So what do? Same thing we were doing with linear polynomials, quadratic polynomials, cubic polynomials, what we just did with a quartic polynomial. When polynomial has degree n equals 9, same thing. P of x is x minus 4 times x minus 3 times x minus 2 times x minus 1.5 times x minus 1 times x plus 0 minus 0 times x plus 1 times x plus 2 times x plus 3. All of that, you can leave it in that form, you can distribute and get this super long polynomial which doesn't even fit on the page here. And this works for any degree. I think in this tool we can only go up to n equals 9, but if you have degree 47, it'll work there too. You find all the zeros and plug it into this basic format to find the function of the polynomial. So if they say, here's a graph, look where it crosses the x-axis, or here are a bunch of zeros of a graph, you can figure out the equation of the polynomial by simply using this little format.